Alright, hello again. Today we are going to learn how to graph quadratic functions from factored form. So let's take a look at our first equation. And this first part asks us to solve this equation. This should be very familiar for you. You spent a week reviewing those type of problems on Khan Academy, and then last week we reviewed how to use the zero product property. I see that the best way here, because I have three terms, is to use the x method. I am going to be looking for two numbers that multiply to -6 and add up to +1. Those numbers are -2 and 3. Those are the numbers that I am going to use to split the middle term. -6 x squared is equal to 0. Why did I do this? I hope you guys remember, because now I can group the two terms at the time. Take x out of the first two terms, take 3 out of the second two terms, and look at this again, as always, how convenient. Because this worked, I can now take x minus 2 out, and let's see what's left. X plus 3. Now we are going to use the zero product property, and the zero product property says that I can take x minus 2, make it equal to 0, so x is equal to 2, and I can do the same thing with the x plus 3, so x is going to be equivalent to -3. All right, so we got this. Now we are going to the second part, and now we are going to consider the equation that is y is equal to x squared plus x minus 6. I want everybody to notice how this and this, those two things are equivalent. So given this quadratic equation, can we find the points where the graph crosses x-axis? I want you to see what we did here. What did we plug in? What did we plug in for y? We plugged in for y is 0. And how are we going to figure out the x-axis, where the graph crosses x-axis? So what we are doing is we are finding the x-intercepts. And every time we want to find x-intercepts, we have to make y is equal to 0, which we already did up here. So we know that our x-intercepts are at 2 and -3. Okay? So you will see those are also going to be called zeros. X-intercepts, those are solutions to our quadratic equations. So what I am going to do, because I see this beautiful graph here, I'm going to put those 2 points on the graph. So those are x-intercepts, they are going to be on the x-axis, so there is 2 and -3 is right in here. All right, now the second part says that graphing quadratic equation involves symmetry. How can we use this information to find the vertex for the graph? Well, I will go one step back, and I want to figure out what is the equation for the axis of symmetry. Symmetry. If you did the assignment yesterday, we talked about the axis of symmetry. The axis of symmetry is this beautiful vertical line that is going to go through the vertex. And if we fold our parabola along that line, it is going to nicely overlap. So what I am going to do is I'm going to look at my x-intercepts, and I am going to see, I am literally going to count. So if I go 1 point, it's going to bring me here, 1 point. So I see that my axis of symmetry is going to be at the axis equal to -1/2. I'm going to put it right in here. So I know that x is equal to -1/2. And I also know that -1/2 is going to be the x coordinate of the vertex. So now the difficult part is to find the y coordinate of the vertex. But if we think about this, if we want to figure out at this point, we need to take the x and plug it in everywhere in place of x inside of our equation. So here we go. -1/2 squared plus -1/2 minus 6. Let's see what this is equivalent to. This is 1/4 minus 1/2 minus 6. 1/4 minus 1/2. Well, if I have a quarter and somebody takes away 50 cents, I have negative quarter minus 6. So negative 6 and 1/4. What we just did is we figure out what is the coordinate of the vertex. So now I am going to count very, very carefully. 1, 2, 3, 4, 5, 6 and a quarter. This is where the vertex is going to be. Okay. Now the next thing that we are asked to find is to find the y-intercept. And remember, for every time you are looking for the y-intercept, your x-coordinate needs to be equal to 0. So what I am going to do, everywhere in place of x, I am going to plug in 0. 0 squared plus 0 minus 6, well, that's 0, negative 6. So I know that 1, 2, 3, 4, 5, 6, there's going to be point right there. And I also know that there's going to be point, the axis of symmetry was at negative 1/2, so I know that there's going to be a point that is going to be symmetric to it. Okay, now let's take a look at this one. What else can we say about the graph based on our knowledge of the symmetrical nature of the graph of the quadratic equation? Can we determine the coordinates of any other point? Well, I already answered that question because I knew that my y-intercept was at 0 and negative 6. I also know that there's a point at the same distance from the x-axis, so it's going to be at negative 1 and negative 6. Those 2 points are symmetric, and then I have my vertex right here. We could figure out more points if we wanted to, because I could nicely plug in 1, so I could see what is happening if x is equal to 1. Well, that should be 1 squared plus 1 minus 6. 1 plus 1 is 2, 2 minus 6 is negative 4. So I would know that if x is equal to 1, y is equal to negative 4. I am 1.5 away from the axis of symmetry, so half, 1.5. I would know that this point also belongs to our graph, so I would have a point 1, negative 4, and I would also have a point negative 2, negative 4. I could plug in any point we want, but knowing the general shape of the quadratic equation, it is a U shape, it is a beautiful parabola, I can graph this graph. Okay, and behavior as x goes to positive infinity, y is going to positive infinity. As x goes to negative infinity, y or our function values are going to go to positive infinity as well. I am going to do one more example, and then you will do the remaining 3 for your assignment. So I am going to do this one because it seems to be the most difficult one. So what I want to do is I want to graph the following function and identify key features of the graph. So this equation is not in a factored form. You will see some of them are going to be, some of them are not. So because it's not, we need to factor it first. But what I do see is, I see that there's a greatest common factor. So I'm going to take negative 6 out. X squared is left minus 6x plus 5. Always double check. Negative 6x squared, positive 36x, negative 30. That's fine. We are not done. 2 numbers that multiply to 5 and add up to negative 6. Well, that is going to be negative. What are the 2 numbers that multiply to 5 and add up to negative 6? Negative 5 and negative 1. So negative 5 and negative 1, I already noticed that I can use the shortcut. So I am going to have -6, that's the number that I factored, and you will see it is going to be important because it's negative. And it is also going to do something with our parabola, you will see in a second. I am going to have x minus 5 and x minus 1. So I am going to follow the same step as in the example number 1. I am going to solve this, and I am going to say that x minus 5, x minus 1 is equal to 0 to find the x-intercepts. So I see that x is equal to 5 and x is equal to 1. 1, 2, 3, 4, 5, and x is equal to 1. Okay, those are my x-intercepts. All right, the next thing that we did find in the previous example was my axis of symmetry. So what I am doing is I am counting. Okay, if I go 1 away, 2, that is going to be nicely right in here. This is where the axis of symmetry is. So I know that the axis of symmetry is at x is equal to, one more time, 1, 2, 3. And to figure out the vertex, I am going to plug in 3 everywhere in place of my equation, and you can either use the original one or you can use the factored form. I am going to use the factored form. So -6 times 3 minus 5 times 3 minus 1. That is -6 times 3 minus 5 is -2. And 3 minus 1 is 2. That is going to give me 1224. And it is going to be positive 24. So, well, I think if we count every 2, 4, 6, 8, that's not enough. 24 is divisible by, let's see, 8. So if we do, if we go by 4, so if this is 4, 8, 12, 16, 20, 24, I know that my vertex is going to be here. I am going to be writing underneath now. We knew that the x-coordinate was 3, and the y-coordinate, we found that it is 24. Okay, next thing that we did find was the y-intercept. And to find y-intercept, we have to set x is equal to 0. So everywhere in place of x, I am going to plug in 0. This is 0, this is 0, so the only thing that I have is -30. Again, I went by 4, so 4, 8, 12, 16, 20, 24, 26. Well, I would be somewhere here. So I know that my y-intercept is at -30. Knowing that this is at -30 and knowing that I am 3 units away from the axis of symmetry, I know that there's going to be 1, 2, 3, another point directly across from the axis of symmetry. Notice that this parabola is going to look differently. It's going to still have a U shape, but it's kind of stretched, and we will talk about this very soon. And it looks like this. Think about the negative sign. The negative sign in front of our function, in front of our equation, flips the parabola with respect to the x-axis. So that is going to happen. If there's going to be a negative sign with the highest exponent, your parabola is going to be open down. All right, you will have A, B, C, to finish, and make sure you also finish the notes. If you need extra paper, please feel free to use extra paper, but make sure you make as nice graph as possible, even if you are just using a regular piece of paper. Have fun with that.